All right. With this one, we're going to need to employ a few of the things that we've learned in our complex numbers section. Notice that it is z to the 4 minus 8i, z squared minus 25 equals 0. I don't have real coefficients. It's going to mean that I can't assume complex conjugates, and I'm also not going to be able to check my answer with my calculator, because my polynomial solver doesn't work if I have complex coefficients. I think the place to start would be if I notice I've got a z to the power 4 and a z squared. Maybe if I let z squared equal k or x or something, I could use my quadratic formula to factorize. I definitely couldn't factorize it just as it is. And then I could get some sort of a value for z squared. And maybe from there I could work with my z squared. Okay, let's have a look. So we have z to the 4 minus 8i z squared minus 25 equals 0. And I'm going to try letting z squared equal x. So that then means I've got an x squared minus 8ix minus 25 equals 0. And I'm going to use my quadratic formula because I can see I'm not going to be able to factorize that. So x is negative b plus or minus the square root of b squared minus 4ac all over 2a, and that gives me 8i plus or minus 8i squared minus 4 times 1 times negative 25. What's your signs with your quadratic formula? All over 2. And that gives me 8i plus or minus 64i squared plus 100 over 2, and that means I have 8i plus or minus, well, 64 times I squared is negative 1, so 100 minus 64 gives me 36, and the square root of 36 is 6, and I can divide everything by 2 so that I get 4i plus or minus 3. Okay, that means that x is equal to 4i plus 3, or x is equal to 4i minus 3. But I'm not solving for x, I'm solving for z. So x is equal to z squared. So therefore, z squared is going to be, and let's get it in the form that we're used to, 3 plus 4i, or z squared is going to be negative 3 plus 4i. All right, now I've got a quadratic root and another quadratic root, and I need to solve those. Let's deal with each one separately. Okay, so let's consider z squared is 3 plus 4i. Now I can let z, because this is in Cartesian form on my right hand side, let's let z equal a plus bi, where a and b are real numbers. So I can say that a plus bi squared has to equal 3 plus 4i, and that means that a squared plus 2abi plus b squared I squared is 3 plus 4i, and I squared is -1, so a squared minus b squared plus 2abi must be equal to 3 plus 4i. Now, that might not feel like I'm making much progress. However, I've got a real component here and a real component here. I have an imaginary component here and an imaginary component here. And if I equate them, I'm actually going to have two equations, and I can solve those two equations simultaneously. So let's have a look at that. I'm just going to shrink this a little bit so that I can finish it over here. So equating real imaginary components. I have that a squared minus b squared is equal to 3. And I have that 2ab is equal to 4. Perhaps I want to make a is going to be equal to 2 over b, just so that I can rearrange that nicely. All right, and maybe we're going to call that equation 2 rather than the first one so that we can easily communicate it. Now all I need to do is substitute equation 2 into equation 1. And this should feel very similar to what we did earlier in the term when we were solving simple complex numbers. So substitute 2 into 1. So I've got 2 over b squared minus b squared is equal to 3. So that gives me 4 over b squared minus b squared is equal to 3. And I can multiply every single term by b squared so that I get 4 minus b to the 4 is 3b squared. And let's take the b to the 4 over. I think it's easier to deal with there. Plus 3b squared minus 4 equals 0. And I can factorize that because I've got a b squared there and a b squared there. 4 and 1 plus 4 minus 1. And I have a null factor law. Okay, and that gives me that b squared is -4, or b squared is equal to 1. Now, if b squared was -4, that would imply that b is plus or minus 2i, or b is plus or minus 1. But we were told over here, or we decided that a and b were both real numbers. So a solution of plus or minus 2i for b doesn't make sense. So we're going to discard, as b is a real number. Okay, so you need to give a reason why you're discarding. So we've got values of b of plus or minus 1. So we're wanting to say when b equals +1, let's work out what a is. Well, a was 2 over b, so a is equal to 2. And when b is -1, a is -2. Okay, so that means that z is going to be plus or minus 2 plus or minus I. Okay, so it's a plus bi. All right, so that means that z is going to be, my pluses and minuses are in the same order, plus or minus 2 plus I. Those are my roots for my first part of my equation. And I'm going to run out of a lot of space here. So what I'm going to do is I'm going to shrink this hugely for the second part of my equation. All right, so now we've considered z squared is 3 plus 4i, we now need to consider z squared is minus 3 plus 4i. So now consider z squared is negative 3 plus 4i. And we're going to go through the same process, okay, where we're going to let z equal a plus bi, where a and b are both real numbers. So therefore my a plus bi squared is going to be negative 3 plus 4i, and a squared minus b squared plus 2abi is negative 3 plus 4i. And again, we're going to equate our real and imaginary components. And then we get, I didn't think it would like that word, a squared minus b squared is negative 3 as our first equation, and 2ab is equal to 4, and that gives me that a is equal to 2 over b. Okay, so now I'm going to substitute 2 into 1 so that I have 2 over b squared minus b squared is negative 3. 4 over b squared minus b squared is negative 3. 4 minus b to the 4 is negative 3b squared. And I can take that across, makes it easier. Minus 3b squared minus 4. And they've made it nice and easy for me to factorize again. This time it's going to be negative 4 and plus 1. And I'm going to give myself a little shrinkage here again. When you're working in this, you probably want to give yourself a bit more space. And I've got a null factor law. So we have b squared is equal to 4, or b squared is negative 1. In this case, b will be plus or minus 2. And here b is going to have to be plus or minus I. And again, we said that a and b are both real numbers, so we're going to reject as b is a real number. And when b is equal to positive 2, a is going to be equal to, and what did we say? It was 2 over b, so positive 1. And when b was negative 2, a is negative 1. So therefore, my solutions will be plus or minus 1, plus or minus 2i. And because the pluses and minuses are in the same order, 1 plus 2i are my roots. Okay, so my solutions then are going to be plus or minus 1 plus 2i and plus or minus 2 plus I. Okay, so therefore z is equal to plus or minus 2 plus I and plus or minus 1 plus 2i.